You guys are probably missing my awesome jokes, my comedy. So if I think of anything while we're going through this problem, hopefully you'll laugh. All right, let's go ahead and start this. So we need to find the area of R. We're doing part A. So first, you need to put these two equations in your calculator. It's easy to set up your windows because they give you some nice numbers, but we need to find the intersection points of these. So I would do one of these. Let y1 equal sine pi x. That tip's a little fat. Let me shrink it down. And we'll do let y2 equal the other function. Put those in your calculator. And then we need to find the intersection points. We shouldn't assume it's 0 and 2. It might not be. So we can say y1 equals y2 at. If you find those intersection points, they come out nicely. It is x equals 0 and 2. So it makes it nice and easy. So to find the area, we have to add up a bunch of rectangles. So I will make pretty red rectangles. And there's one of them. There's another. And it goes all the way across. So the first one will start at 0. The last one at 2. So how do we add up all of those rectangles? Well, you guys should know. You integrate to add them up. And we want to add them up starting at 0. The last rectangle will be at 2. So I guess the problem here would be, what's the height and the width of each rectangle? So clearly that width there is a change in x as you move left and right. So that will be dx. And the height, I guess we can call this h. Whenever you want to find the distance between 2 points, it's going to be big Y minus small y. And the bigger y is the sine function, so it's going to be y1 minus y2. So we should do the area, which will be, I'll go height times width, which will be the h we had there, y1 minus y2. I'll go ahead and put y1 minus y2 times the width, which would be dx. You pop that into your fancy schmancy calculator, and it comes out nicely as 4, I hope. I'm just looking at the scoring guidelines. Let me go ahead and do my calculator. It's going to take some time here, but let me try it. Math 9, 0 to 2, y1 minus y2, and I get 4. All right, that would have been worth 3 points. That was pretty easy. All right, part B is going to get kind of different, but let me go ahead and erase all of this nonsense. Well, it's not nonsense, but all this work we did to look at part 2. So we have a horizontal line, y equals -2. So I guess I should erase all this. All right. So y equals -2. I'll draw a line. Bam. There it is. So it splits region R into 2 parts. Write but do not evaluate an integral expression for the area of the pi to r that is below the horizontal line. Okay, that's not too bad. I think we can handle this. So first of all, we need to find those intersection points. So now we want to do this. That's going to be y2. y2 will equal -2 at. So on your calculator, graph y3. I'm going to make that equal to -2. If I graph that, I can find the intersection point. So we're going to do second trace. We're going to calc the intersection point, so you can choose 5. But you got to be careful because now you have 3 functions, y1, y2, and y3. So when it says the first curve, you want to hit your up and down arrow till you're on the sine graph. And enter. When it asks for the second curve, make sure you're on your horizontal line y equals 2. And then guess. Move it to that left intersection point. And we have the first intersection point. I'm going to store it as A, 0.5391. And remember, go to your home screen. So hit second quit and hit X store alpha A, and that will be stored for you. Then we're going to calculate the other intersection point. So go to second trace intersect, and again select the 2 proper graphs. Whoops, I just messed up and I chose the wrong ones. So I'm going to start all over. Intersect. There's my first graph. There's my second graph. And if you do it right, you should get 1.667. And I'm going to store that. So second quit, do X store B, alpha B. Okay, I have those numbers stored. Whoa, I just realized my numbers aren't right. I messed up. Let me back up and find that B correctly. Let me try it again. Second calc intersect 1.6751. Now I'm going to store that correct number as B. So now we're going to do the same process we did last time. We need to add up all the rectangles. And the first one is right the left edge, and they go all the way across again. The last one is there. So how do we add up those rectangles? We do the same thing. We're going to go from A to B, because this was A and that was B. I guess I should make those red. Point A and point B. So it's the same process. We want to add up all the areas, and the areas are going to be the height times the width. Now clearly the width of that is going to be a change in X. The height, let's see, I'm going to use another color, purple. That's going to be the height. Let me call this H2 because it's a different H from the first one. And that's going to be the blue line, which is -2, minus that sine function, which I called, what I call it, not sine function, actually the x cubed. That's going to be y2. So I punch those in. The integral from A to B, -2 minus y2. The thickness or the width is dx. I'm going to pop that in my calculator and hopefully it comes out with the right answer. Do math 9 from A to B. And it's going to be -2. Make sure you hit the negative, not the minus sign. I know some of you had a problem with it on a test like that. Select Y2. And I hope my answer comes out right. Oh no, I wasted all that time and it didn't ask for an answer. That's actually the answer. I don't have to calculate it, so we are done at this point. But for fun, if you did want an answer, it comes out to be about 0.811. So that's part B. We have 2 more parts to go. Let me erase all that work. Back up, get my eraser, and we will do part C. Let me get rid of this one also. I don't need any of this. And that blue line, I should be able to get rid of that. Okay. So we are placing in part C cross sections. So a picture of building with the floor R, and it's coming out of the paper. So it's standing, and if you cut slices, you would get rectangles, or squares. Let's have a purple building. So that is a slice. And those slices come out, so I don't know if you can even picture this. They come out of the screen. And the shape is a square. And you have those all the way across. There's the base. And it's rising up out of the paper. So, to get the volume of all those, you have to add the volume of all the little slices up. So, how do you add up a bunch of things? You integrate, again, from 0 to 2. And we want to do a volume, which is the area of the shape, which is a square, times the thickness. And again, the thickness is a change in x. Let's see. The thickness would be that width, which is a change in x. And so we have a square. The area of a squared is going to be a side squared, and the thickness is dx, where this length is s. Looks like upside down 5. That's an s. And so s in our case would be big Y minus small y. We did that earlier in part A. It's going to be y1 minus y2. So let's see, do they want the answer? They do want the volume, so we're going to integrate from 0 to 2. It's going to be y1 minus y2 squared dx. I'm going to pop that in my calculator, just like that. Math 9, 0 to 2. I need to add an extra parentheses. So it's already there, a parenthesis. I'm going to add another one. I'm going to do y1 minus y2, end the parenthesis, square that whole thing with respect to x, and hopefully I get the answer that they have. Bang! Awesome. It's 9.978. And that's the answer to part C. We're almost done. Now we're going to go to part D. And this should look familiar. I think you had this similar problem on your test. that I gave you on this stuff. So this one, you're going to have to use your imagination a little bit here. I can't erase that. I don't know what's going on. So if you're in a helicopter looking down, R is the top of a pond. And we have grass growing around a pond, long grass all over. It's like a grass field, so hopefully you can kind of see. So we're flying above this. There is the grass. All right, so the pond has different depths. This formula here describes the depth. If you know X, you know the depth of the pond. So if you look right here, where that red dot is, X is 0. So the depth of the pond would be 3 minus 0, or 3. So it's deeper right there. Now if you go to the middle of the pond, where that red line is there, X is 1 there. So if you want to know how deep the water is there, it's going to be 3 minus 1, or 2 units deep. I don't know if we're feet, inches, what are we? It doesn't say. So the farther we move to the right, the more shallow it is. So how do we find the volume? So kind of the same situation. If we choose any slice, they're going to have different depths. So let me erase this. Which color? The water's blue, so I'm going to pick blue. So if you pick this slice, which is X is 1, the depth is going to be 2. So if you picture it going underneath, hopefully you can see that dotted line. That's underneath. At that point, the depth would be 2. Now if we picked a slice over here, since X is much smaller, at that point, the depth will be almost 3. So at that point, the depth of the water is deeper. That's like almost 3. And then if we took a slice out here, the depth of the water is going to be 1. So if it goes underneath, it's not going to be 1. It's going to be bigger, but you can picture it being like 1 there. So if you can see, it's the same thing. We're adding a bunch of rectangles up. And the volume will be the area of the rectangle times the thickness. So here we go. Purple's a nice, pretty color. To get volume, you have to add up all the volumes. And we start at 0 and end at 2 like before. But the volume on all of these is going to be the area of the shape times the thickness. And if you look, the width of this is going to be a change in X of all my slices. So the thickness of that will be dx. What's the area of a rectangle? Well, let's see on our picture. We'll call this L. Ooh, let me get a different color so you can see it better. Let's use red. So this is L. And this part right there, we'll call H, because that's our formula. It's H down here. So the area of that triangle is going to be that length times that height. The height of the rectangle, which is the depth of the water, is H down there. So we're done with H. We just need L, but we did L in part 1. That's the big Y, which is the sine function y1, minus the smaller y, which is y2. So the area is going to be length times width, and the thickness is dx, or not the width, we called it h. No, eraser, help me. length times the height of the rectangle times the thickness. L is just y1 minus y2. And h is this function right here. So you'd actually push that. You could put that as y3 on your calculator, I guess. That's going to be h of x dx. So join me putting that into your calculator. So we'll do math 9 from 0 to 3. And I'm going to put an extra set of parentheses. And I'm going to do y1 minus y2. I wish you could see my screen. And the parentheses. Then I'm going to either put h in. I'll just put it in. Parentheses. 3 minus x. Close parentheses. And then put dx. And my answer should come out perfect. No! Why is it different from theirs? I am sad. I am confused. Something is wrong. y1 minus y2, 3 minus x. Okay, let me try that again. I don't know what happened. I don't know. Oh, me estúpido. I see what happened. This is not 3. I messed up. I put 0 to 3. It should be 0 to 2. And in my calculator, I put 3. So I'm going to scroll up, re-enter that, put in a 2, and my answer should come out perfect. Oh no, what happened? Enter. Perfect. 8.369 or 8.370. 8.369 or 8.370. We are finished with this problem. I didn't think of any good funnies. I apologize. But one down, many more to go. I'll post this on YouTube and let you know. Bye-bye.